pleasant afternoon to everyone. So Group 3 is in front of you again in your screen to discuss Chapter 9, Database Management Systems. Kung maaalala natin sa Chapter 1, we've already discussed about the two general data management approaches, the flat file model and the database model. First, we will have a short recap on what are the major differences of the two approaches. So flat file versus database approach. So flat file approach. Flat file systems were defined as legacy systems pero kahit na outdated na yung systems, technologies, or software applications na ginagamit ng organization, patuloy pa rin nila itong new-utilize since they can still fulfill the duties they were designed to accomplish. But this approach faces two issues. First is its company culture creating hurdles between the firm. Second derives from the restriction in systems resulting for the data to be reorganized and replicated. So in figure 9-1, depicted this situation. Makikita natin dito na may tatlong users requiring the following data. We can notice that the data letter B is present to all users. This is called data redundancy. Because of this, there are three concerns formed: the data storage, data updating, and currency of information. There is also an indirect difficulty, the task data dependency, which we will discuss later on. An effective information system gathers and stores data only once and it is accessible by all users. But in flat file model, this is not the case. This resulted to raise the cost of additional collecting and storage procedures to satisfy the required private data of users. Data updating. Generally, necessary data must be updated regularly. For instance, may customer na nagbago ng location, so need itong i-update sa corresponding master files. If the departments such as sales, billings, credits, etc. keep separate files, all changes must be done individually for each user, increasing the cost document processing greatly. Currency of information. The difficulty in this aspect is that while conducting numerous updates, the records of all users affected by changes must be notified. Kung hindi na-distribute sa lahat ng users ng ayos yung information, maaring yung decisions nila ay nakabase lamang dun sa outdated or obsolete information. Task data dependency. It is when user fails to acquire additional details required to update a task. This occurs when the user requires information that is already available in the set of another users. So for example, figure 9-1 illustrates that if user 1's information needs to be adjusted and kailangan niya yung data Y na makikita na natin sa user 2. Since wala namang interconnection yung mga users, hindi pwedeng i-access ni user 1 yung data ni user 2. At possible rin na hindi sila aware na already existing na yung data Y kay user 2. Dahil dito, they will produce data Y from scratch, which will lead to redundancy and greater data management cost. The database approach. Figure 9-2A explains how the database strategy varies from the flat file concept. Mapapansin natin na lahat ng data ay nasa isang database na lang and is accessible by all users. So here is the comparison between the two approaches side by side. It is evident that the idea of data sharing which diminishes one's control over the information is prevalent. That being said, the flat file problems have been resolved. So it eliminates data redundancy since every data is saved only once. Since each data items appear only once, single update operation lang yung required. Those updates will also notify all users at once in its current values. Users are also entitled to the whole scope of data and there is no task data independence. Pero makikita rin natin na walang restrictions yung data. To demonstrate, data M is confidential at si user 2 lang yung dapat na may access dito. The database management system is now introduced to resolve this issue. So the database management system or DBMS stands between the user's program and the physical database. It is seen in figure 9-2B that it limits database access. It is a particular software that is configured to know which data each user is permitted to retrieve. Yung user ay magre-request sa DBMS and once na-verify ito, bibigyan ni si user ng authorization and i-reject naman pag hindi authorized si user na i-access yung data na hinihingi niya. Early database models. Early database models, which illustrates the database method, vary from modern database models. This is due to the fact that it is based on standard flat files. The following are the most typical database techniques being used in corporate data systems. Number 1, hierarchical database. It adheres to rankings or a parent-child connection. Network database, same with hierarchical but enables the child's account to link with numerous parents' record, allowing two-way connections. Lastly, relational database. It is a table-oriented and it is more adaptable since it allows users to connect via the database. Dahil same ng concept ang hierarchical and network databases, they were referred to as navigational or structured models. Kahit na part na ito ng legacy systems, patuloy pa rin itong ginagamit pero mostly ng businesses, relational databases na yung ginagamit. Elements of database environment. The database environment is divided into 4 major elements. First is users, database management systems, database administrator, and lastly, physical database. In this figure, we can see how each elements are connected to each other, so let us discuss each element thoroughly. The first element is users. The figure displays how users access the information in two ways. The first is through user application software developed by system specialists. Dito nagre-request si user sa DBMS, then the queries are evaluated and collects the information needed for processing. The second way is the direct query. So, walang program na ginagawa rito. Makikita nating diretso agad sa DBMS si user and di na need mag-request, hindi gaya ng sa first way. Database Management System, the DBMS offered a regulated setting for managing data assets effectively. Some common aspects that each DBMS types achieved are program development. This feature uses to construct database accessible apps since it includes software development tools. Backup and recovery. Gaya ng backup and recovery natin sa ating mga phones, DBMS produced copies of the physical database. Once na may mga unforeseen events, they can restore a prior iteration that is guaranteed to be accurate. Possible na may ilang data na mawala, pero mas okay na may ma-recover ang firm kaysa wala. Data usage report. This function collects details on what and when data is used as well as who will utilize it. This information is applied by the database administrator to assist with user authorization and database maintenance. Lastly, database access. This is DBMS' fundamental and most vital function. It provides the database's access to authorized personnel. Under this, there are 3 software components illustrated in 9-3. Under database access, we have data definition language, data manipulation language, and query language. Data definition language. It is a software language that defines the actual database of DBMS. It consists of the names and relationships of all data components, records, and directories that comprise the system. DDL specifies the database on 3 different levels, known as views, which can be seen in Figure 9-4. First is internal view. It is the lowest point and displays the physical structure of the record in the database. Next is conceptual view or schema. It denotes the database conceptually and inductively rather than physically. Lastly, user view or subschema. It specifies how a specific user sees the area of the database that are permitted to view. Makikita natin na ang user view consists of numerous user perspective, while the conceptual and internal view ay may isang area lang. To illustrate the rules of the views, let us discuss this figure. For example, a user requests a data to the DBMS, then ililipat yung request sa data manipulation language na i-discuss natin sa susunod na slide. The DBMS analyzes the request. Kung match yung data na na-request ni user sa conceptual view, the user is authorized to process the data proceeding to step 3. And if not, the access request is denied. So, number 3, from the internal view, ililipat na yung mga data sa operating system at doon nagaganapin yung data retrieval. This is called the access method. Number 4, from the operating system, the data will be retrieved from the physical database. 5, the data will then be stored in a main memory buffer area managed by the DBMS. 6, it will then be transferred to the user's work location. Dito pwede nang gamitin ni user yung data. And lastly, when the process is complete, steps 4, 5, and 6 are reversed to restore the process data to the database. Data manipulation language. It is the specialized language of programming implemented by a certain DBMS to collect, process, and store the data. DML are instructions that enable legacy software applications for use to simply adapt them to function in the current database environment. Query language. It allows the users and experienced developers to easily retrieve the database's information without the use of traditional application. It has evolved as the query language interface for both mainline and microcomputer DBMS. SQL or Standard Query Language is a fourth-generation, non-procedural system with several commands that enables users to conveniently input, retrieve, and alter data. Dito, meron sila command na malaki ang tulong to gather data. Figure 9-5 in particular indicates the usage of the select function to generate a user report from the inventory database. To demonstrate, itong inventory database ay may specific attributes na makikita natin sa taas ng table. Ang hinahanap lang ay data from items, description, on hand, warehouse location, VIN number na ang on hand ay greater than 300. So automatic na inilabas ng interface yung data gamit yung SQL commands. Database Administrator. They are in charge of the database resources. Different users using a single database need structure, collaboration, rules, and standards to ensure the databases safely. We can notice that the DBA administers the DBMS. Sa malaking corporation, binubuo ng isang department of technical experts ang DBA. Kung isang maliit na firm naman ay may isa or higit pang tao ang nagsusupervise ng responsibilities ng DBA. These responsibilities are divided into the following categories as shown in Table 9-1. First is database planning. It includes develop organization's database strategy, define database environment, data requirement, and develop data dictionary. Next is database design. It includes logical database or schema, external users views or subschemas, internal views of database, and database controls. Next is the database implementation. It also includes determine access policy, implement security controls, specify test procedures, and establish programming standards. Then database operation and maintenance that evaluates database performance, reorganize database as user needs demand, and review standards and procedures. Lastly, the database change and growth that plans for change and growth and evaluate new technology. For more information, we have Ms. Martel to discuss it further.
To further discuss the database administrator, Figure 9.6 shows the organizational interactions that involve the DBA, and one of which is of particular importance, that is between end users, the DBA, and the systems professionals or programmers of the organization. Whenever the need for information arises, users send formal requests to systems professionals for computer applications. The systems professionals then deal with said requests through formal systems development procedures which produce the program applications. The same requests also reach the DBA who evaluates these to ascertain the database needs of the users. And once they have, the DBA grants the user access authority by programming the user's view. Access authority is kept separated from systems development so that the organization can control and protect the database better. It's also because it's easier to discover intentional and unintentional attempts at unauthorized access when these two groups work independently. Next is the data dictionary. The creation and maintenance of the data dictionary is one of the important functions of the DBA. This describes every data element in the database. It also enables users to share a common view of the data resource and facilitates the analysis of user needs. The fourth and last element of the database approach is the physical database. It is the lowest level of database and consists of magnetic spots on magnetic disk. The other levels of the database are abstract representations of the physical level. Also, at this level, the database is a collection of records and files. The next figure, figure 9.7, depicts the index sequential file. Relational databases are based on the index sequential file structure. This structure uses an index along with a sequential file organization. It also facilitates both direct access to individual records and batch processing of the entire file. Multiple indexes can be used to create a cross-reference called an inverted list. which allows even more flexible access to data. Going back to the illustration, two indexes are shown: employee number and year-to-date earnings. Indexes may be created for each attribute in the file, allowing data to be viewed from a multitude of perspectives. We have already mentioned relational databases, so let's now proceed with the relational database model. In the late 1960s, E.F. Codd proposed the principles of the relational model. It is founded on relational algebra and set theory, which provide the theoretical basis for most of the data manipulation operations. According to purists, a fully relational system follows the 12 strict rules indicated by Codd. However, not all of these rules are critical nor important. Therefore, for practicality reasons, other theories suggested a less rigid or more flexible set of standards in assessing the relational standing of a system. Consequently, a system is considered relational if it represents data in the form of two-dimensional tables, such as this table called the customer. Another is the system supports the relational algebra functions of restrict, project, and join. Restrict, as illustrated in figure 9.9 letter A, extracts specified rows from a specified table. It creates a virtual table that is a subset of the original table. Presented in letter B is project, which extracts specified attributes or columns from a table to create a virtual table. Lastly is letter C, join. Join builds a new physical table from two tables consisting all series of pairs of rows. These three are an incomplete set of relational functions. However, they are a useful subset that fulfills most business information needs. Moving on to relational database concepts, this section encompasses basic concepts, terminology, and techniques common to relational database systems, which are also the foundations that will be used later in this chapter to create a small database from scratch. Entity, occurrence, and attributes. Entity is anything about that an organization aims to gather data. It may be physical, such as inventories, customers, or employees, or it may also be conceptual, like sales, accounts receivable, and accounts payable. Each entity in a data model is named in the singular noun form. Example, customer instead of customers. System designers identify entities and prepare a model of them, like the one presented in figure 910. This data model is the blueprint for ultimately creating the physical database. It is called an entity relationship or ER diagram. Occurrence, on the other hand, is the number of instances or records that refer to a particular entity. For example, an organization has 100 employees. The employee entity is said to consist of 100 occurrences. Another is attributes. These are data elements that define an entity. Attributes are the logical and relevant characteristics of an entity. They are unique to it. Therefore, the same attribute should not be used to define two different entities. Each occurrence in a particular entity may consist of the same types of attributes. Values of each attribute will vary among occurrences. Association and cardinality. Association. The labeled line that connects two entities in a data model represents the nature of association between them. It is characterized by verbs such as ships, request, or receives. Subsequently, cardinality is the degree of association between two entities. It describes the number of possible occurrences in one table that are associated with a single occurrence in a related table. There are four basic forms of cardinality: 0 or 1, 1 and only 1, 0 or many, and 1 or many. These are combined to represent logical associations between entities. To elaborate further, here are examples of entity associations. Example 1. Assume that a company has 1,000 employees, but only 100 of them are sales staff. Assume also that each salesperson is assigned a company car and non-sales staffs are not. In this example, for every occurrence in the employee entity, there is a possibility of 0 or 1 occurrence in the company car entity. On the other hand, each company car is assigned to one and only one employee. In this example, our entities are the employee and company car. This is their association line, the line that connects the two, and their association is described by the verb assigned. Now, mayroong mga symbol sa magkabilang dulo ng association line. Two short lines sa employee end at isang circle and short line sa company car end. Anong ibig sabihin nito? These symbols describe the number of possible occurrences in one entity that is associated with a single occurrence in a related entity. In short, ito yung tinatawag na cardinality or the degree of association between two entities. Banggit kanina na 100 out of 1,000 employees are sales staff, meaning yung 900 ay non-sales staff. Then each salesperson is assigned one company car. Therefore, if an employee is a non-sales staff, he or she is not given a company car. So for every occurrence in the employee entity, there are two possible occurrences in the company car entity, 1 or 0. An employee who is a sales staff is assigned one company car, whereas an employee who is a non-sales staff is assigned 0 company car. In the illustration, this is represented by the circle with one short line. Company car entity's perspective, on the other hand, a company car is assigned to one and only one employee. One and only one employee who is a sales staff receives a company car. Hence, the two short lines at the employee end of the association line, which represents the cardinality of one and only one. Example 2. Each company laptop computer is assigned to only one manager and every manager is assigned only one computer. Ang nasa magkabilang dulo naman ng association line between the manager and laptop entity ay two short lines. And we all know that this represents the cardinality of one and only one. Every manager is assigned one and only one computer, and each company laptop computer is assigned to one and only one manager. In the third example, ang nasa magkabilang dulo ng association line ay isang two short lines and a circle with the crow's foot symbol. We all know from a previous example that the circle means 0. But what does the crow's foot symbolizes? From the customer entity's perspective, a customer may have purchased nothing at all or several times. So for every occurrence in the customer entity, the two possible occurrences in the sales order entity are 0 or many. If the circle represents 0, then the crow's foot symbolizes the cardinality of many. Example 4. As we can see, there's also a crow's foot symbol on one end of the association line between the two entities in example 4. And as we have discussed in example 3, the crow's foot symbolizes the cardinality of many. However, it's with one short line this time, which represents 1. This is because each vendor supplies one or many different items of inventory to the company. Meaning, for every occurrence in the vendor entity, there are two possible occurrences in the inventory entity, one or many. Example 5 also represents the association between the vendor and inventory entity. However, assume that the company has a policy where the same type of inventory is purchased from multiple suppliers. This is commonly done by management to ensure that they get the best prices or avoid becoming dependent on a single supplier. Therefore, in this example, both ends of the association line has one short line with the crow's foot symbol, which represents the cardinality of one or many. This is because the vendor is associated with one or many inventory records, and each inventory is associated with one or many vendors. We can also conclude from example 4 and 5 how cardinality reflects the business rule implemented within an organization. Therefore, the database designer must obtain a thorough understanding of how the client company and specific users conduct business to properly design the data model. If not, the resulting database tables will also be wrong. Alternative cardinality notations. The crow's foot symbol shown from previous examples represents the many cardinality, and this can be alternatively written on each end of the association line as the exact cardinality values. Therefore, if the two possible occurrences associated with an entity are 1 and 3, 1 and 3 will be explicitly shown or presented on the association line.
So next topic is the physical database table, which are constructed from the data model with each entity in the model being transformed into a separate physical table. So there are properly designed tables that possesses four characteristics. First is that the value of at least one attribute in each occurrence or row must be unique. So this is actually the primary key. So the values of other non-key attributes in the row need not to be unique. Second is that all attributes in any column must be of the same class. Third, that each column in a given table must be uniquely named. However, different tables that may contain columns with the same name. Fourth is that the table must conform to the rules of normalization, which means that they must be free from structural dependencies, including repeating groups, partial dependencies, and transitive dependencies. Next is linkages between relational tables. So logically related tables need to be physically connected to achieve the associations described in the data model. Using foreign keys accomplishes this. So a foreign key is a field of collection in one table that refers to the primary key of another table. So with a given example here, yung figure 9.12, makikita natin na meron tayong apat na table. First is the customer table, the sales invoice, the cash receipts, and the line item. Since given na sa definition ng foreign key na dapat present yung primary key na yon sa another table. So example is the cost number or the customer number. Present siya sa ng customer table. Present siya sa sales invoice, this one, and present rin siya sa cash receipts. Similarly, another example, itong invoice num na primary key ng sales invoice, present siya sa line item table. Pero merong nagde-differ sa line table. Meron siyang dalawang composite primary key, which is the invoice number and the item number. As we can see dito sa illustration na to, napakita yung paglilink ng bawat table to each other that makes it easier para maintindihan natin. Yung customer number, nasa sales invoice, and nasa cash receipts, and so on. So, nakikita natin na connected siya sa associations described in the data model. So next is the user views. So a user view was defined as a set of data that a particular user sees. This is a view part or all of the contents of a database to spread a particular purpose of user activity. So one crucial obligation kasi ng isang database designer that has implication of internal control is to locate all views and convert them into normalized tables. So next strategies and problems associated with this are undertaking or at look at. So there are three examples of user views, which is management reports, computer screens for entering or viewing data. Third is the source documents like invoice. So simple views may be constructed in a single table, while more complex views may require several tables. Examples are large organizations that will have thousands of user views, which means that they will also have thousands of individual table support. Next topic naman is database anomalies. So a database anomaly is a fault in a database that usually emerges as a result of a shoddy planning and storing everything in a flat database. Improperly normalized tables might result in DBMS processing issues that limit or even prevent users from accessing the data they require. there are actually 3 types of anomalies. First is the update anomaly, which is a data inconsistency that results from data redundancy and a partial update. Second is the insertion anomaly, which means that inability to add data to the database due to the absence of another data. Third is a deletion anomaly, which occurs when you delete a record that may contain attributes that shouldn't be deleted. So there are levels of anomalies that will exist if tables are not normalized. First is the first normal form, or the 1NF. Second is the 2NF, or the second normal form. Third is what we aspire kung ano yung kailangan natin, which is the third normal form, or the 3NF, which is a table normalized to be free from anomalies. So meron tayo ditong isang table, which is the inventory status reports of the Ajax Manufacturing Co. Dito natin magagamit yung mga susunod na table. Ito yung content din niya. So meron ditong part number, description, quantity on hand, order point, the supplier number, the name, address, and telephone number of each suppliers. So para mas maintindihan natin yung mga unnormalized database table, ito yung given na gagamitin natin. So first, para mapakita natin yung update anomaly, let's look at supplier number 22. So as a recap, ano nga ba yung update anomaly? Ito yung data redundancy. So si supplier number 22, nasa part number 1 siya, part number 2, and part number 3. It means na in every part, nagsusupply siya ng different inventory. So nakikita natin dito na paulit-ulit nga siya. Ano nga ba yung problema doon? So, bigay tayo ng iba pa example. Paano kung umorder ka ng 10,000 different items sa isang supplier? Does that mean na 10,000 different times mo din siyang uulitin? Yun yung data redundancy. Yun yung update anomaly. Second is the insertion anomaly. Since walang given dito that shows insertion anomaly, bigay tayo ng scenario. So, meron yung Ajax Manufacturing Company, nakakita sila ng bagong supplier na gusto nilang ilagay sa database, pero hindi pa sila nagpa-purchase doon. Ibig sabihin, hindi nila pwede ilagay yung supplier na yon doon sa table because of the table design. Bakit? Kasi nga, ang primary key nito is the part number. Paano ka maglalagay ng part number sa isang supplier na hindi ka pa nabili? Yun yung insertion anomaly. Third one naman is the deletion anomaly, which means that when you delete a record that contains attributes that you might need. So example natin naman sa deletion anomaly is supplier number 27 of part 1. Halimbawa, so kung makikita natin dito, isa lang yung sinusupply niya. Sa part number 1 lang siya. So, paano pag yung company piniling mag-discontinue yung pag-delete kay supplier number 27? Automatically, madidelete lahat ng information niyan because of the table design. Pero, kahit gusto ng company na i-keep yung information niya for later use, halimbawa kung bibili ulit sila, hindi na possible yun. Since yun nga yung aim ng deletion anomaly. An unnormalized database table. So a flawed database design that inhibits record insertion or necessitates frequent changes immediately draws attention. However, the deletion anomaly might go undetected, which would prevent the users from realizing the loss of crucial data until it was too late. So, critical accounting records may unintentionally be lost. As a result, audit trails will be destroyed. Since alam naman natin na as accountants, audit talaga yung pinaka-basis in making decisions. So, table design is actually used for operational effectiveness, and that accountants need to also understand that kailangan din yung table design na yun for internal control. Next is normalizing tables. So the database anomalies described above are symptoms of structural problems within tables called dependencies. Mayroong tatlo, which is repeating group, partial dependencies, transitive dependencies. So the resulting tables will then meet the two conditions below. First is that all non-key data attributes in the table are dependent or defined by the primary key. Second is that all non-key attributes are dependent of the other non-key attributes. To explain it further, a 3NF, yun yung goal natin na normalized table, is one in which the primary key of a table fully and uniquely defines each attribute in the table. So furthermore, none of the table attributes is defined by an attribute other than the primary key. If any attributes violates these conditions, they need to be removed and placed into a separate table and assign an appropriate key. So para mapakita natin siya, linking normalized tables. So when normalized tables are split into multiple tree and F tables, they need to be linked together via foreign key so the data in them can be related and made accessible to the users. So meron na naman tayong table dito na pinakita na split na into tree and F. So first table, second table, and the third table. Paano ba natin mapapakita na nalilink natin sila sa isa't isa? So the part supplier link table, itong part number, na-link natin siya sa inventory table through putting part number din here while adding another columns like descriptions, quantity on hand, and reorder point. Malilink din natin ng part supplier link table through the supplier number. As you can see, given siya sa parehas na table, which means that the supplier number with different informations lang from the suppliers like name, address, and telephone number. Next is the degree of association. We actually have three. First is the keys in 1:1 association. So where a true 1:1 association exists between tables, either or both primary key may be embedded as a foreign key in the related table. On the other hand, when the lower cardinality value is 0, a more efficient table structure can be achieved by placing the one side table's primary key in the 0 or 1 table as a foreign key. So this just means na nag-exist yung 1:1 association pag yung primary key, it's either the primary key or both the foreign key is in the related table. Next is the keys in 1:M association. So where a 1:M association exists, the primary key of the one side is embedded in the table of the M side. So meron tayong table here para mapakita natin yan. So ito yung one side, ito yung M side. So, based dun sa definition ng 1:M, the primary key of the one side, ang primary key natin is the supplier number, embedded din siya sa M side, which is here. Nasa supplier number din siya. So nandito na rin naman, explain na din natin yung business rule number 1. So each vendor supplies the firm with 3 or fewer different items of inventory, but each item is supplied by only one vendor. So para ma-explain to, makikita natin, gamitin natin example si supplier number 28. Makikita na sa supplier number 28, nagsusupply din siya to part number 1 and part number 3, which means different items of inventories but supplied by only one vendor. Next is business rule number 2. So each vendor supplies the firm with any number of inventory items, but each item is supplied by only one vendor. So si naman, supplier number 22 naman, makikita rin natin na nagsusupply din siya with any number of inventory items. Nagsusupply din siya kay part number 1, which is part of the company. So sa business number 1, this is considered unrealistic, but technically possible as this business rules describes this as an upper bounded 1:M association. So while in business number 2 naman, this is a true 1:M association in which the upper limit of the many side of the association is unbounded. Last part ng joint cardinality is the keys in M:M association. So to represent the M:M association between tables, a link table needs to be created. So the link table has a combined composite key consisting of the primary keys of the two related tables. So meron din tayong table dito to further understand. So given dun sa ito yung 1:M key na ni-reverse lang to fit the M:M key association. So makikita dito yung na-present yung, as we know, the foreign key, the part number 1, 2, and 3 sa primary key ng many side. So foreign key ng one side, part number 1, 2, and 3, present siya sa primary key ng many side, part number 1, 2, and 3. So dito din applicable yung business rule number 3, which means that the vendor supplies the firm with any number of inventory items, and each item may be supplied by any number of vendors. This means that an M:M association between tables require the creation of a separate link table because embedding a foreign key within either table is not possible. Kaya siya sineparate kasi nga impossible nga daw yung pag-embed ng foreign key sa primary key. So, yun po.
Next topic is about accountants and data normalization. Data normalization, for instance, the update anomaly can result in contradicting and obsolete database entries. The insertion anomaly can lead to unrecorded transactions and incomplete audit trails, and deletion anomaly can result in loss of accounting records and erasure of audit trails. With that being said, normalization of databases from this anomaly should be handled and a responsibility of the system professionals. Although most accountants will not be involved in normalizing companies' databases, but they should understand the process and be able to determine if the table is properly normalized, in which may have implications in internal control and that make it the concern of the accountants. Next is designing relational databases. This examines the steps involved in creating relational databases. Database design is a portion of a much larger systems development process that involves an extensive analysis of user needs. And there are 6 phases of database design or known as view modeling. First is identify entities. View modeling begins with identifying the primary entities of the business function in question. To show entity identification, we first analyze the following key features of a simplified purchasing system. First, the purchasing agent reviews the inventory status report for items that need to be recorded. And this shows in this figure 913 the example of the inventory status report, which includes the part number, description, quantity on hand, reorder point, supplier number, name, address, and telephone number. And then the agent selects a supplier and prepare an online purchase order. And this is the example of the purchase order, which contains importantly the purchase order number, supplier name, supplier address, part number, description, order quantity, unit cost, and total cost. And then the agent prints a copy of the purchase order and sends it to the supplier. Lastly, the supplier ships inventory to the company. Upon its arrival, the receiving clerk inspects the inventory and prepares an online receiving report. Then the computer system will automatically update the inventory records. And this is the example of the receiving report, which is shown in the slide. And to pass as valid entities, there are conditions to be met. First condition, the entity must consist of 2 or more occurrences. Second condition, the entity must contribute at least one attribute that is not provided through other entities. And there are a number of candidate entities. First is the purchasing agent. If the organization has only one agent, then it fills the conditions. But if more than one agent exists, condition 1 is met, but condition 2 may be a problem. Assuming a human resources or payroll system has an employee database and basic agent employee data are in the table, we must determine what order placing specific agent data to record. Not order data, but agent data. We presume no agent-specific data are recorded because our system description is concise. Therefore, the purchasing agent candidate is not an entity to be modeled. Second, receiving clerk. Just like the previous one, we assume that no clerk-specific data needs to be captured that require a dedicated table. And inventory, this meets both of the condition as the description suggests that the organization holds many items of inventory, which results to contain multiple occurrences. The inventory entity is a true entity that can be modeled as it also cannot be seen in other tables. Next is supplier. Based on figure 913, the description states multiple vendors supply inventory. Therefore, supplier entity meets condition 1 and we may assume that it also meets condition 2 as there is no other entity that will logically provide supplier data. Consequently, the supplier entity can be modeled too. Next candidate entity is inventory status report. It is a user view derived from inventory and supplier entities. And you can see, as you can see in the figure 915, the normalized database tables, it may contain multiple occurrences, but it is still not considered as an entity because it does not satisfy the condition 2, for the reason that the view is derived entirely from existing entities and provide no additional data that require a separate entity. Next is purchase order. Both conditions are met by the purchase order. The entity will have many occurrences because it processes many purchase orders. Some purchase order data can be derived from other model entities, the inventory and supplier entity, but the order date and quantity require a separate entity. Lastly, the receiving report. This satisfies both conditions because in this period, many receipt events will occur, so receiving report will have multiple occurrences. A receiving report entity has unique attributes like date received and quantity received that aren't provided by other entities in the model. The four entities mentioned, the inventory, supplier, receiving report, and purchase order will be used to construct a data model and the physical database table. In constructing a data model uh, showing entities associations, this is the second step in view modeling to determine the association between entities and documents with an entity relationship diagram or ER diagram. For example, the normal association between a customer entity and sales order entity is one-to-many. This means that one customer may place many orders during the sales period. The organization's business rules directly impact the structure of the database tables. If the database is to function properly, its designers need to understand the organization's business rules as well as the specific needs of individual users. The underlying business rules are explained with the use of the data model showing entity association here in figure 919. There is zero-to-many association between purchase order and inventory entities because each inventory item may have been ordered many times or never in the current business. We assume that the purchase order table will contain records for purchases made in the current period only. And many-to-many association between inventory and supplier entities, which means that one or more vendors supply each inventory item and each of them supplies one or more items. And one-to-many association is between the supplier and purchase order entities, in which in the current period each supplier received zero or many purchase orders, but each of it goes to only one supplier. And one-to-one association between the purchase order and receiving report entities, in which a single receiving record reflects the receipt of goods that are specified on a single purchase order record, and multiple purchase orders are not combined into a single receiving report. And lastly, zero-to-many association between receiving report and inventory entities signifies that within the period, each item of inventory may have been received many times or never. And third phase is adding primary keys and attributes to the model. The third step in the process in which in adding primary keys, the analyst should select a primary key that will logically define the non-key attributes and uniquely identifies each occurrence in the entity. This can be accomplished using simple sequential code such as invoice number, check number, or purchase order number, as shown in the figure 920 in data model showing primary keys. While in adding attributes, entity attributes are derived and modeled from user views. So if stored data are not used in a document, report, or calculation, then it serves no purpose and should not be part of the database. Every attribute in an entity should appear directly or indirectly in one or more views. Fourth phase is normalizing the data model and add foreign keys. Normalization issues that needed resolution are outlined in the following section, which are based on normalized data model. First is repeating group data in purchase order. It includes part number, description, order quantity, and unit cost. And repeating group data in receiving report includes part number, quantity received, and condition code. And additional information about the composite key, it is composed of part number and receive receipt number. And transitive dependencies, it shows that there is a redundant with the data in inventory and supplier entities. Next is constructing physical database, which is presented in this figure 923, which is the normalized tables. The dotted line shown here is the primary and foreign keys linking the tables. Base design is prepare the user views. Normalized tables should support all system users' views. In the slide, an example of purchase order in users' views is shown, which could be a purchasing clerk's data entry screen constructed from several tables. To show the relationship, the circled numbers link user view fields to supporting table attributes. A relational database management systems or DBMS query function lets designers create user views from tables. The designer tells the DBMS which table to use, the primary and foreign keys and table attributes. To illustrate the SQL command needed to produce the inventory status report illustrated in this figure 913, which is the inventory status report, are given in the following section, in which will be based on the normalized data model. So based on figure 922, which is the normalized data model, the select command identifies all of the attributes to be contained in the view. When the same attribute appears in more than one table, for example, the part number, the source table name must also be specified. The from command identifies the tables used in creating the view, and the where command specifies how rows in the inventory, part supplier, and supplier tables are to be matched to create the view. In this case, the three tables are algebraically joined on the primary keys, part number, and supplier number. And multiple expressions may be linked with the AND or and NOT operators. These SQL commands will be saved in a user program called a query. To, to view the inventory status report, the purchasing agent executes the query program. Each time this is done, the query builds a new view with current data from the inventory and vendor tables. By providing the user with his or her personal query rather than permitting access to the underlying base tables, the user is limited to authorized data only.
Global view integration. A contemporary business might require hundreds or thousands of views and related tables. A view integration is the combining the data needs for all of the users into a single schema or enterprise-wide view. To facilitate this task, modern enterprise resource planning or ERP systems come equipped with a core schema, normalized tables, and view templates. The best practices databases are derived from economic models that identify commonalities among the data needs of different organizations. For example, all organizations that sells products to customers will need an inventory table, customer table, and a supplier table. Many of the attributes and keys in these tables are also common to all organizations. The view modeling method then includes configuring or modifying predefined views to meet particular user requirements while working from a core ERP database. ERP vendors cannot, however, anticipate the information needs to all of its users in advance. Therefore, new tables and new attributes may need to be added to the core schema. The data designer must produce a set of integrated tables that are free from update, insert, and deletion anomalies and sufficiently rich to serve the needs of all users. Databases can either be a distributed or centralized as a solution to this problem, giving the planner two basic choices. Partition databases and replicated databases are the two types of distributed databases. The issues, attributes, and trade-offs covered in this section should be carefully considered when choosing how databases should be distributed. The central site performs the functions of a file manager that services the data needs of the remote users. The centralized database approach is illustrated in this figure 9-24. So primary advantages of database approach. First is the reduction of data storage costs. Second is the elimination of multiple update procedures. And third is the establishment of the data currency. Data currency in a DDP environment. Account balances go through a temporary discrepancy during the processing where their values are misrepresented. Immediately after the execution of the instruction number 3 and before the execution of the instruction number 4, the AR control account value is temporarily inconsistent by the sum of $2,000. This inconsistency is resolved only after the completion of the entire transaction. In a DDP environment, such a temporary inconsistencies can result in the permanent corruption of the database. On this figure, it shows more of the potential damage that it can do in the information. Using the same computer logic as before, consider the processing of the two separate transactions from two remote sites. First is the transaction 1 or the T1 is the sale of $2,000 on account to customer Jones from site A, and the transaction 2, which is the T2, is the sale of $1,000 on account to customer Smith from the site B. The following logic shows the possible interweaving of the two processing tasks and the effect on data currency. Database lockout. A database lock is used to lock some data in a database so that only one database user or session may update that particular data. So database locks exist to prevent two or more database users from updating the same exact piece of data at the same exact time. So to solve this problem, the database lockout may be of help as if it is a software control that prevents multiple accesses to the data. To illustrate this technique using the previous example, once the central site, the DBMS, receives the access request from site A for AR control, T1 instruction number 2, it immediately places a lock on AR control to prevent access from other sites until transaction T1 is complete. Consequently, site B is placed on wait status when a requests AR control. Only can site B access AR control and complete transaction 2 when the lock has been lifted and removed. Distributed databases. The distributed databases can be distributed using 1. The partition technique and 2. The replicated technique. Distributed databases. These distributed databases can be distributed using 1. Partition technique, 2. Replicated technique. A partition database splits the central database into user-accessible segments. Advantages of partition database. First is local storage increases user control. Then, allowing local data access and reducing data transmission improves transaction processing response time. And lastly, partition databases reduces risk. By storing data at multiple sites, the loss of one site would not stop all the data processing. Accountants needs to be aware of the problems with stalemate resolutions because of the implications for transaction processing. For site 2 naman, meron siyang lock sa C and waiting for E. Finally, yung sa site 3 has a lock on E and is waiting for A naman. Based on the given problem, a deadlock occurs here because there is a mutual exclusion to the data and the transactions are in a wait state until the locks are removed. This can lead to faulty databases and incompletely executed transactions. the deadlock resolution. So one or more transactions must often be sacrificed in order to break a deadlock. So to finish processing the other transactions in a deadlock, meron dapat na mapahinto. Preemptive transactions must be started again. The deadlock resolution software tries to resolve the deadlock for the least amount of money as possible by preempting the transactions. Despite the being challenging to automate, here are some following variables to influence these. So for on the first one, the quantity of updates could be used to evaluate these. The number of transactions already performed must be repeated if the said transaction is terminated. And on the second one, broadly speaking, the deadlock resolution software will not abandon the transactions that are almost finished. Then on the second one, broadly speaking, that the deadlock resolution software will not abandon the transactions that are already or almost finished. Then lastly, on the third one, because determining the transaction breaks all the deadlock involvement, the software should try to end the transactions that are involved in more than one deadlock. Replicate databases. Some organizations replicate the entire database at each location. In businesses with a high level of data sharing but no primary user, the replicated databases are effective. Due to the replication of common data at each site, the data traffic between the sites is significantly reduced. On figure 9-27, it shows the model of the replicated database. A replicated database primary purpose is to support the read-only queries. With the data replicated at each time, the data access for query purposes is ensured and the network traffic bottlenecks and delays are minimized. So, nagkakaroon lang ng problema kapag yung local sites ay kailangan din mag-update ng replicated database with the transactions. Figure 9-28, pinapakita ng illustration na to yung effect ng processing credit ng sales na para kay Jones sa site A and kay Smith sa site B using the data from earlier. After processing, the value displayed for the common AR control account is inconsistent. So, merong $12,000 at site A and $11,000 at site B. Concurrency control. Database concurrency refers to the completeness and the accuracy of the data at all remote sites. So this task has implications for accounting records and is a matter of concern for accountants, hence its significance. To serialize transactions, the commonly used method is the concurrency control, which involves labeling each transaction with two criteria. So the two criteria are, first is to identify the potential conflicts that the special software groups transactions into classes. Example is the read-only query transactions. Next is the timestamp each transactions. Some of the sites may have different time zones and the time will only be logically the same when using a system-wide clock. Each timestamp is made uniquely by incorporating the site's identification number. When transactions are received at each location, they are initially analyzed for potential conflicts. So the transactions are entered into a serialization schedule if the conflicts exist. An algorithm is utilized in order to schedule database updates based on the transaction timestamp and class. This method allows multiple interleaved transactions to be processed as serial events at each site. The decision to distribute databases is one that should be thought of carefully. There are many issues that trade-offs to consider, so some of the most basic questions to be addressed are: so first, should the organization's data be centralized or distributed? Next is if the data distribution is desirable, should the databases be replicated or partitioned? Next is if replicated, should the databases be totally replicated or partially replicated? And lastly, if the database is to be partitioned, how should the data segments be allocated among the sites? The organization's capacity to uphold the database integrity is impacted by the decisions made in each of these questions. The accuracy of accounting records and the preservation The organization's capacity to uphold database integrity is impacted by the decisions made in each of these questions. The accuracy of accounting records and the preservation of the audit trails are important issues. Clearly, modern accountants need to be aware and skillfully influence these choices. And that's all for our group report for Chapter 9 Database Management System. Thank you for listening and have a nice day.